Hey guys, it's Stanford here with First Updates Now, and today I'm with Team 4481, Team Rembrandts, and we're going to be looking at their absolutely incredible robot, covering the path that their game pieces go through to get scored. They've got an amazing 4-bar intake, a really cool cone spindexer, and a really good extending arm. And I'm here with Niels, Joris, and Julian, and we're going to be highlighting a lot of the cool stuff on this robot. Stay tuned for all that and more on another episode of Behind the Bumpers.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25.
All right, so first we have Niels talk about this fantastic intake that we've seen here. So Niels, take it away.
Yes, thank you. Like I already said, it's a 4-bar intake. It's 2 wheels and they are both inverted. You can see that with these cross belts that are crossed, so the wheels are inverted. It's way easier to get the cones inside. Also, if the cones stand up straight with this bar over here, the cones will get knocked over and the cubes can be get in every orientation because it's a cube. Also, there's a second roller in here. This is here, so it's also loose, as you can see. The roller is here because to make sure that there are no dead zones in the intake, and that really works really good. And everything, also there's a little bell over here, so everything is powered with just one Neo. And we can also have a little bit of a demonstration if the intake gets taken out. Here you can see everything working in its path and just really. Yeah, the cones can be getting inside with every orientation possible. It doesn't matter.
Really cool. Definitely one of the most effective intakes that I've seen this competition season. And so now we're going to talk about the next thing that their game pieces go to is this amazing spindexer. So I have Joris to help me describe what's going on in there.
Before I actually start talking about the spindexer, I'll first explain a bit of our strategy for this game. For this game, we really wanted to add in the touch-it-own-it element that many typical shooting games have, even though this is a more so pick-and-place kind of game. To this, we made this intake that can pick up both game pieces in any orientation, with the downside of having to still index or orientate the game pieces within our robot. Hence, because of this, we made the spindexer. It's quite an ingenious design, and it's made of a spinning plate that indexes the game pieces, hence the name spindexer. How it works is you have the plate here that spins around and that orientates the game pieces, and you also have a combination of a mechanical latch, a sensor down here and a sensor down here that all work together to see or to detect where our game pieces are located and how they are orientated. And this way we can completely automatically have the robot itself orientate our game pieces correctly so we can move them on during the game. Now we'll give you a small demonstration of how it actually works in practice. So they'll put in the cone. So here you just saw how it quite quickly automatically orientates the cone and then automatically picks it up so that once we arrive at the grid, the driver can decide to score it wherever he wants.
That is really cool. But I did notice something in here that looks like a flexible 3D printed component. Could you go into more detail about that?
Of course. Like you said, this is a custom 3D printed flexible component, and we use it as a sort of mechanical latch. Something quite interesting about it is depending on the side you push it, it has either gives very easily or has quite some resistance behind it. So for example, if the spindexer spins this way, you can push through it quite easily. But if you have the spindexer spin around the other way, there's quite some resistance, and you need to use this cutout to actually push the cone through it. And this, in combination with the sensors, makes for almost 100% accurate system to make sure the cone is always orientated correctly to be moved further within our system.
That is really cool. Definitely one of the coolest things I've seen in a robot this year. And the last thing we're going to talk about is this incredible arm that they have to actually score these game pieces. So, Julian, if you want to open up about that.
Yeah, so after we've got our cone into a robot and we've indexed it, of course we still have to be able to score it. So to score it, as you could see in, when Joris showed it, the arm goes in and picks up the orientated cone. And using this gripper, we can choose whether we want to pick up a cone or a cube. The size of, the spread of these wheels is adjusted using the cylinder. And then by turning the wheels with this Neo, we can suck in the cone or the cube. Then, of course, we still have to score it on different nodes. So to do that, we have this chain, which is powered by a gearbox and a Neo to flip up the arm. And then we also have a belt that drives our inner tube to extend our arm so we can score in the high position, and we can also score in the mid position. And low is, so it extends for low, so it's close to the ground and it just falls a little bit. We put it back in and it lays there. And the entire extending arm, as I said, is driven by a belt. This belt is attached on the inner tube and is then driven by a pulley, a Neo, and as you can see, this is how it works.
So these guys have been absolutely fantastic here at the 2023 Port Hueneme Regional. Some incredible features on this robot. So definitely look out for it at other competitions, and good luck with the rest of your competition season, guys.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.